Hello, welcome to Mathematics in the Modern World Lesson 2, which is the set theory. First thing is, what is a set? A set is a collection of well-defined objects which are distinct from each other. Sets are usually denoted by capital letters A, B, C, and so on, and elements are usually denoted by small letters A, B, C, and so on. Now, what are the examples of sets? We have here the set of students in this room, the English alphabet, and the set of natural numbers. Element of a set. If A is an element of a set A, then we write A is an element of A or A is a member of A. Example, let set A is equal to A, B, C. A is an element of A, B is an element of A, and C is an element of A. If A does not belong to A, we write A is not an element of set A. Example, determine whether the statement is true or false. So we have set A, which consists of numbers 1, 2, 3, and 4, and set B, which consists numbers 5, 6, 7, 8, and 9. So we have the first one. 6 is an element of A, is false. Number 2, 8 is not an element of B, is false. Number 3, 5 is an element of B, is true. Number 4, 4 is not an element of B, is true. So let's proceed on the methods for describing a set. So the first one is the roster listing method or tabular form. In this method, a set is described by listing element separated by commas within braces. So here are the examples. We have set A is equal to A, E, I, O, U. Set B is equal to blue, red, yellow. Set C is equal to juice, coffee, wine. The next one is the set builder or rule method. In this method, we write down a property or rule which gives us all the elements of the set by that rule. So here are the examples. Set A is equal to X such that X is a vowel of English alphabets. Set B is equal to X such that X is a color of the rainbow. Set C is equal to X such that X is a day of the week. So let's proceed on types of sets. So we have the first one, the finite set, a set which has a countable number of elements. So meaning, yung number ng elements sa loob ng set na yon ay kaya nating bilangin. Next is yung number 2, yung cardinality of a set. Ito is yung number of elements in a given finite set denoted by NA. So we have here an example. So set A is equal to null set. Ngayon, ang tanong ko, ilang elements ba ang na kay set A? Okay, very good. 0. So, ang cardinality ngayon ni set A is equal to 0. How about yung cardinality ni set B, which consists numbers 5, 6, 7, 8, 9? Now, ilan ba yung elements na nasa loob ni set B? Okay, very good. Meron tayong 5 elements sa loob ni set B. Letter C, we have A, B, C, D, E, F, G. Now, what is the cardinality of set C? Okay, very good. 7 dahil sa loob ni set C, meron tayong 7 letters. So, let's proceed on the third one, the infinite set. A set containing a not countable number of elements. So, meaning, yung elements sa loob ng set na ito ay hindi na natin kayang bilangin. Example, yung isang set is meron siyang million of elements, trillions, or more. Next is yung empty, null, or void set. A set containing no element. It is denoted by circle with a line or two braces. So meaning empty, wala siyang laman. Next is Singleton Set. A set containing a single element. So itong set na to daw is meron lang siyang isang element sa loob ng set. So example is si set A, which has only number 1. Si set B, which has blue. Next is yung equal sets. Ito daw is yung two sets A and B are said to be equal if every element of A is a member of B and every element of B daw is a member of A. And we write A is equal to B. So, ang example natin dito is ito. X, Y, Z is equal lang siya kay Y, Z, X. Next is yung 1, 3, 5, 7 is equal lang daw siya kay 7, 5, 3, 1. The 7 is the equivalent sets. Two sets are said to be equivalent if they have same number of elements. If cardinality of A is equal to cardinality of B, then A and B are equivalent sets. So we have here an example. So we have 2, 3, 4, 5 is equal to A, B, C, D. They are equivalent sets because they have both 4 elements. The next one is 2, 4, 6 is equal to 5, 10, 15. They are also equivalent sets because they both have 3 elements. So let's proceed to the subset. These are sets whose elements belong to another set. So example is set A is equal to 1, 2, 3, 4, 5. Set B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, A is a subset of B since it could be seen that all elements of A is in B. Next is the proper subset. If A is a subset of B and A is not equal to B, then A is called proper subset of B and we write A is a proper subset of B. Example, let's set A is equal to 1, 2, 3. The proper subsets of A are 1, 2, 3, 1 and 2, 1 and 3, and 2 and 3. Next is the universal set. A set consisting of all possible elements which occurs under consideration is called a universal set. Next is a power set. It is a collection of all possible subsets of any set. The number of elements of a power set is denoted by PA is equal to 2 raised to n, where n is the number of elements. So let's have the example. Let set A is equal to 1, 2, 3, 4. Now class, how many elements are there in set A? Okay, very good. There are 4 elements. So we use the formula P of A is equal to 2 raised to n. We just substitute n with 4. So it will become PA is equal to 2 raised to 4. So PA is equal to 2 times 2 times 2 times 2. Now what is 2 raised to 4? Okay, very good. It is 16. Now, what are those 16 elements or the possible subsets? So, we have the null set 1, 2, 3, 1 and 2, 1 and 3, 1, 4, 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4, and 1, 2, 3, 4. So, count them all together. They are all 16 proper subsets. So, let's proceed on Venn diagram. In a Venn diagram, the universal set is represented by a rectangular region and a set is represented by a circle or a closed geometrical figure inside the universal set. So let's move on the operations on sets. So the first one is the union of sets. The union of two sets A and B, denoted by A union B, is the set of all those elements, each one of which is either in A or in B or both in A and B. So we have here an example. Set A is equal to 1, 2, 3. Set B is equal to 3, 4, 5. So the A union B is equal to 1, 2, 3, 4, and 5. The diagram shows that set A and B is shaded because it is the union of A and B. Next is the intersection of sets. The intersection of sets A and B, denoted by A intersection B, is the set of all those elements which are common to both A and B. So we have here an example. Set A is equal to 1, 2, 3, 4. Set B is equal to 3, 4, 5, 6. A union B is equal to 3, 4. And the figure below shows that the intersection between A and B is shaded as red because it denotes the A intersection B. Next is the complement of a set. If A is a set with U as universal set, then complement of set A, denoted by A prime, is the set U minus A. The complement of set B, denoted by B prime, is the set U minus B. So the illustration shows the A complement and B complement. Lastly, we have the differences on sets. For two sets A and B, the difference A minus B is the set of all those elements of A which do not belong to B, and also with those elements of A which do not belong to A, which means B minus A. The figure below shows A minus B and B minus A. Thank you for watching. I hope you have enjoyed and learned a lot. See you in our next lesson. Goodbye.